How are you doing, Isaac? Good. Glad to hear that. Just letting people come in real quick. See here. You guys will have your second exam on the 11th, which is it's going to be due on Sunday. Okay, so over here, what we have to do is cover 3.3, 3.5, 3.7, then we can review. Just letting people come in. It doesn't seem like there's a lot of people. There's 7 in right now. Yeah, it holds a gallon. It holds a gallon. Plus, you don't have to drink out of plastic. Yes, drinking a lot of water is part of staying hydrated and healthy. Woo. Okay. Let's see here. Now let's look over here at our modules. Did I sign up for the Zoom membership? What do you mean by that? Yeah, I know. Yeah, that's something the school is supposed to be paying for. That's something OSU-OKC is supposed to be paying for. So I don't know why that's happening. I'm signed in using my OSU-OKC information, and so I guess I guess it's their fault. I'm not sure why that's happening. Your English professor has it? Okay. So to honor that, let me write my colleague an email right away and ask them about that. Done. Email is sent. We'll see why that's happening real quick. All right. But until then, we're just gonna have to deal with what we have, even though it's very annoying. I agree. Okay. So we're at 3.3. Actually, we're almost done with 3.3. If I take a look through here. Actually, we are done with 3.3. I thought we had some stuff left, but we don't. So it's actually 3.5 and 3.7 in the review. Let's go back here. We'll get to the bottom of it and see why. Transformation of functions. All right. All right. To talk about graph transformations, first let's graph one of our favorite functions. Let's say we want to graph one of our favorite functions, the parabola. Meaning the parabola is given by f of x is equal to x squared. All right. Then we know how to graph things. We create an f of x table. Right? So to see what our f of x is equal to x squared looks like, we pick some sample points, symmetrical points about the origin. Let's say -2, -1, 0, 1, and 2. Then we evaluate the function at these points. So what is f of -2? Well, that's equal to -2 squared, which is equal to +4. What is f of -1? Well, that's just -1 squared, which is equal to 1. What is f of 0? Well, that's just 0 squared, which is equal to 0. What is f of 1? Well, that's just 1 squared, which is equal to 1. And f of 2, well, that's just 2 squared, which is equal to 4. So we come over here, we put our -2, our -1, our 1, our 2. We go to -2. We find 4 on the y. 1, 2, 3, 4. I go to -2 on the x. I go to y 4 and I put a dot. Then I go to -1. I find a 1. I put a dot. Then I go to 0. I find a 0. I put a dot. Then I go to 1. I find a 1. I put a dot. Then I go to 2, I find a 4, and I put a dot. Then what do we do with the dots? We have to connect the dots. To see what the graph looks like, merely connect the dots. Well, that is our graph. But guess what? We can transform our graph. We can cause a graph transformation. Hence this right here. And so what does f of x, well, let's call it a new thing. Let's call it a g of x. What does g of x is equal to let's say x minus 1 quantity squared look like? All right. Well, the way we can discover that is by doing an g of x table, right? Well, so we'll just do a g of x table. G of x table. We'll pick some points, let's say -2, -1, 0, 1, and 2. What is g of -2? It's just whenever I replace our x with a -2. So it's -2 minus 1, all of that squared. But that equals -3 squared. And -3 squared is +9. So I put a +9 here. What is g? What is g of -1? Oh, well, that's just my -1 minus 1 all squared. But that's -2 squared. -2 squared is +4. What's our g of 0? Well, that's just 0 minus 1 squared, which is just -1 squared, which is just 1, +1. What is g of 1 squared? What is g of 1? That's just 1 minus 1 all squared. But that's the same thing as 0 squared, and 0 squared is 0. And last but not least, what is g of 2? Well, that's just 2 minus 1, everything squared. Well, that's just 1 squared, which is 1. So let's graph this in yellow. I go to -1, I find a +9, and I put a dot. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. So I go to -2, I find a +9, and I put a dot. I go to -1, I find a +4, I put a dot. I go to 0, I find a 1, and I put a dot. I go to 1, I find a 0, and I put a dot. I go to 2, I find a 1, I put a dot. Okay, let's do one more point. What about f of 3? Or g of 3, I mean. G of 3 is equal to 3 minus 1 quantity squared, which is 2 squared, which is 4. So then at 3, I go to 3, I go to 4, and I put a dot. So then let's connect these dots. Wow! Would you look at that? What is that? Do you guys see what just happened? What just happened? Can someone tell me? How does the yellow dot look different than the white? How does the yellow graph look different than the white graph? It shifted. Where did it shift? To the right. Yeah, it did. It went to the right. And did it go to the right? Did it shift horizontally or did it shift vertically? Horizontal, yes. You will see that whenever we have a function, let's say we have a function f of x, then its graph can get transformed to a f of, let's say, x minus a h, where h is your horizontal shift. If you transform your graph from your f of x to a f of x minus h, then it will shift your graph to the right by h units. Notice that that is what happened with our f of x is equal to x squared, and our f of x is equal to x minus 1 squared. Notice that this is your f of x. And notice that this is your f of negative, this is your f of, well, we called it g of x, but really it's your f of x minus 1, which is the same thing as your g of x. Because g of x is defined as x minus 1 quantity squared. So notice the fact that this transformation results in a horizontal shift by h units to the right. A different transformation, let's say transforming f of x to f of x plus h, this would cause a horizontal shift to the left. And I know what you're thinking. That is counterintuitive. Minus makes me think I need to go left, and plus makes me think I need to go right. But this is resulting in a horizontal shift to the right, and this is resulting in a horizontal shift to the left. It is counterintuitive, but whenever you plug it into your f of x table, that is what happens. Let's prove that. What about, let's define a function Let's define another function. Our original function was f of x is equal to x squared. All right. Then we transformed it to f of negative. We transformed it to f of x minus 1, which becomes quantity x minus 1 squared. Let's transform f of x to a different value. Let's say f of x plus 1. All right. Meaning that that's equal to x plus 1 quantity squared. Let's make an f of x table with this guy to test our hypothesis. So let's do -2, -1, 0, 1, and 2. These will be our test values. Okay. So what is f of -2? Well, that's just -2 plus 1 quantity squared. So this becomes -1 squared, which is 1. I put a 1 here. What is f of -1? Well, that's just -1 plus 1, everything squared. Oh, that becomes 0 squared, which is 0. So I put a 0 here. What is f of 0? Well, that's just 0 plus 1, everything squared. Well, that's just 1 squared, which is just 1. What is f of 1? Well, that's just 1 plus 1 squared, so that must be 2 squared, which is 4. And f of 2, that's just 2 plus 1 squared, which is just 3 squared, so this must be 9. So I'll do this one in red. I'll go to -2. I'll find a 1. I'll put a dot. Oh, whoops, wrong spot. I go to -2, not -1, -2, +1, I put a dot. I go to -1, I find a 0, I put a dot. I go to 0, I find a 1, I put a dot. I go to 1, I find a 4, I put a dot. I go to 2, I find a 9, and I put a dot. Let's connect these dots here. Oh, well, it seems like I would like to find maybe a -3. What is the function at -3? What is f of -3? Well, f of -3 is equal to -3 plus a 1 squared. That's -2 squared. So that's +4. So over here, I go to -3. I find a +4. I put a dot. I can connect that to the rest of the dots. Wow. Do you guys see what happened? What happened to the red graph in relation to the white graph? It shifted left, to the left once. Yes, that is correct. So in general, this actually works for all functions. So this is the concept of a graph transformation. You get the graph f of x, which was our, for instance, our f of x is equal to x squared parabola, and then you alter it. This alteration leads to a graph transformation. And a graph transformation is what happens when you change your graph and the way it looks like. All right. So in general, if we got a function f of x, changing it to an f of x minus a h is a horizontal shift. Not to the left, though, but to the right. Right. By h units. Same thing if we map f of x to a f of x plus h. It becomes a horizontal shift. But this time it's to the left. By h units. As we've shown here, using the example f of x is equal to x squared. Recall, f of x is equal to x squared. Then our yellow function was, our yellow function is actually x minus 1 quantity squared, right? That's what it's equal to. But technically, that's really f of x minus 1. Because notice that f of x minus 1 is just putting an x minus 1 in for every x we see for here, which makes that. Furthermore, our red is our f of x plus 1, which gives us x plus 1 quantity squared. So, remember, that is what happens to functions in general. But we're not done. These are just horizontal shifts. Why don't we try something more vertical in nature? What if I got our red guy? What if I get f of x plus 1 and I transform it to something else? Let me transform it to f of x plus 1 plus 2 on the outside. Meaning, what I want to look at is what is x plus 1 quantity squared plus 2 look like? What does the graph of this thing look like? So the way we discover what graphs look like is we create f of x tables. All right, and we plug in various values to evaluate the function at to discover a small taste of what the graph looks like. Is everybody following so far? Type in yes or no and let me know if I need to slow down or kind of backtrack and re-explain some stuff. It's going pretty good so far. Very good. Okay, good, good, good. All right, so what is f of -2? That's when I replace a -2 with this every x I see in that. So I put a -2 plus 1, everything squared, and then I add a 2 to the result. Okay, so this becomes -1 squared, which is +1, plus 3, -1 squared, which is +1. +1 plus 2 is 3, +3. Okay, what is f of -1? Well, this results in a -1 plus 1 squared plus 2. This is 0. 0 squared is 0. 0 plus 2 is 2. What is f of 0? Well, that's just 0 plus 1, everything squared, add a 2. Well, then 1 squared is just 1 plus 2, we get a 3. So I just put a 3 over here. What is f of 1? Well, this is merely 1 plus 1, everything squared, add a 2. 1 plus 1 is 2, 2 squared is 4, 4 plus 2 is 6. So I put a 6 over here. What is f of 2, I mean? F of 2 is equal to 2 plus 1, everything squared, add a 2. All right, that becomes a 3 squared, which becomes a 9, add a 2, which becomes an 11. So I put a 10 and an 11 over here in anticipation. Okay, so here's our new graph. All right, let's see. I go to -2, I find a 3. Go to -2, I find a 3. I put a dot. I go to -1, I find a 2. I put a dot. I go to 0, I find a 3, and I put a dot. I go to 1, I find a 6, so I'm going to put a dot. I go to 2, I find an 11, and I'm going to put a dot there. Now I'm going to connect these dots. All right, and now let's see where is it going to be at -3. F of -3 is equal to -3 plus a 1, square it and add a 2. This becomes -2 squared, which becomes +4, plus 2 is a 6. So I go to -3, I find a 6, and I put a dot. So then I go connect that right there. What happened? Compared to the red, what happened to this new white graph? Moved up by how much, Zoe? Is it Zoe? Zoe, yeah. Yes, it was a vertical shift by 2. Notice every red piece went up by 2 units. 1, 2. 1, 2. 1, 2. 1, 2. They all went up by 2 units. So it's as if you picked up the red graph, moved it up by 2 units, and put it down. So adding a number here causes a vertical shift by 2. And subtracting a number from there causes a vertical shift by whatever you subtract from. So let's write this in general. And if you're ever lost, guys, if you're ever lost, just create an f of xx table. So we've discovered that given a function f of x, transforming it to f of x plus a b causes a vertical shift by v units up. Furthermore, transforming it like this to give me an f of x minus v is a vertical shift down by v units. Yes. Now, we got a cluttered board here. We got cluttered graphs. There's so many graphs, I don't have enough colors that show up on the screen. So let's wipe this clean and try another set of things that we can do. All right. Now that we know about vertical shifts and horizontal shifts, what else is there? Well, for instance, let's use f of x is equal to x squared again. We know that this is what the function looks like at -2, -1, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, and -2, it produces a +4, put a dot, and -1, it produces a +2, a +1, and put a dot. At 0, it produces 0, put a dot. At 1, it produces a 1, and put a dot, and at 2, it produces a 4, and I put a dot. Connecting these dots, we get something called a parabola, okay? In white, we have x squared. So what happens when I get our f of x? And we change it to, let's say we multiply it times a number. Let's say 2x squared. Meaning, we multiply 2f of x, which then just results in 2x squared. What happens to the function when we multiply it by a number greater than 1? We don't need to guess. We can just create an f of x table. Let's pick -2, -1, 0, 1, and 2. Okay. F of -2 is the same thing as 2 times -2 squared, which is just 2 times a 4, which equals 8. What is f of -1? That's just 2 times -1 squared, which equals 2 times 1, which equals 2. What is f of 0? Oh, that's just 2 times 0 squared, which is the same thing as 2 times 0, which is equal to 0. What is f of 1? That's just 2 times 1 squared, which is equal to 2 times 1, which is just 2. And last but not least, what is f of, it should say -1 actually right here. It should say -1. But the result is the same. F of -2 is the same thing as 2 times -2 squared. That becomes 2 times 4, which becomes 8. So let me do this in yellow. So I go to -2. I find what is the output, +8. Oh man, I made my graph too big or not scaled appropriately. So let me scale this graph more appropriately here. Where our original was at -2, it produced a 4. At -1, it produced a 1. At 0, 0, 1, 1, 2, 4. So our parabola looked like this. Now, what is, because this is x squared, what does 2x squared look like? That's what we want to know. So at -2, it outputs a +8. So I go here and I put a dot. At -1, it outputs a +2. So I go over here, -1, a 2, I put a dot. At 0, it outputs a 0, put a dot. At 1, it outputs a 2, put a dot. At 2, it outputs an 8, put a dot. So let's take a look at what this looks like. It is indeed still a parabola, is it not? I feel like it's going to flip. Never mind. Okay. It did something though. What did it do? What did it do compared to the white graph? So, since I don't have any answers yet, we will now consider a different graph to kind of see what's going on here. That was multiplying it times a number greater than 1. What happens when we multiply x squared times a number less than 1? Like a fraction. Let's say 1/2. So don't forget, yellow is 2x squared. Now we wish to discover what is 1/2 x squared look like. And we're about to probably get kicked out soon.